All right, it's April 10th, 2017. It's 9:31 a.m. and Gary and I are here looking at developing an Ethereum contract for the RChain membership, and specifically to handle the know your customer regulations, so that someone can in essence purchase a membership on the blockchain and have a verified proof of address, which would be done manually by sending a code to the address that a person is registering, and by postal mail, and then a person can then verify their address with that code that proves they did in fact receive the postal mail, and therefore have a verified postal address. Okay, so we have the contract identity registry. We have a contract owner, message sender, which is the initialization that when we create the contract, we set the owner to be whoever created the contract. And this will be created by RChain once. And we have 3 mappings associated with the contract. Verified by, I put, it really isn't verified by after all, because this contract only contains things verified by RChain. I could just change this to verified by RChain. So when somebody goes to so the hash is computed offline, okay, and I guess you could provide an interface. Where's the hash? I lost it. It's all the way up here. So we could have a web page or something that helps a person compute their hash, or they can use whatever tools they want to compute their hash. So when they register their identity and their hash, okay, they simply provide that the hash of their identity. And that gets set in the claimed mapping. So whoever requested this gets their hash set in. I put a to-do here. This is where they receive the ether for their membership fee, which also covers the cost of sending them a postal email and having somebody do that. What did I do? Set code here. I don't know, we want a hash here, or we just want a string byte 32. I don't know how to decrypt this yet, so I'll just make it a byte 32 for now. and set the code, and we have an encrypted value that was set by RChain for the code, and then we have to I put these capital to-dos in there because they're recognized by the GUIs, so that you have your task list, which is your to-dos.
Oh, cool.
And decode. Encrypted. And then we are going to have if we could just say decoded for now. Then we're going to set verified who to the hash. Okay, not the hash. Verified. We don't have a who here, a message sender. Equals I'll put in decrypted. Okay. Okay, does that make sense? So when they register, they claim an identity, and if they enter the correct code, then it becomes verified. Okay. Okay, this allows RChain to validate an address by any means they want to. And this checks to see if an address is verified or not. All right. Do you want to proceed with this, or do you want to move on to Rosette, or what do you want to do? You know, I would need some coaching. You know, it's time for me to do some learning.
Well, if you need coaching, I need serious remediation.
Well, why don't you ask some questions?
I don't know why I don't do that. I get so lost. I guess I'm embarrassed to show my ignorance.
Now, well, don't be. That's what, we need more people asking questions. And then everybody will understand because all their questions will be answered.
Okay, well, I'll start with the first question. This is written in what?
Solidity. Solidity. And I guess the thing that I'm looking at for examples is I don't know what happened to it. Okay, next question. I just wanted to put a reference in here. And I'm looking for it in the wrong place, obviously. I guess one I did it out here somewhere. Okay, Solidity is a smart contracting language, so they call it.
Right.
They aren't smart and they aren't contracts. Okay, wait. No, we can think of a contract as an object on the web that we can send messages to. And the messages we send are the functions. Okay, we can create a contract, we can send a function to a contract. Got it?
Yeah.
Okay, we can have fields associated with the contract. And I've kept things simple here, as simple as possible. I haven't used any structures or anything. They're all primitive types. Okay, and certain things, when we invoke, whenever we invoke whenever somebody sends a message to a contract, whether it's a creation of a contract or whatever, the message sender is the Ethereum account that invoked the contract, the Ethereum identity. What we're doing here is linking an Ethereum identity to a physical address. Okay, and whoever created the contract will become the owner of it. When we deploy the contract, the owner is set to whoever deployed the contract. All right.
Okay.
And I defined 3 mappings. And the mapping is from an Ethereum address, data type, to a integer 256 whatever, which is the hashed identity of the identity credentials of the factors.
I got you.
Okay, and one mapping has the things verified by RChain in it. And another mapping are the claims that people have made. And the third mapping is the code that we give the person to verify their identity, their physical mailing address.
Okay.
This is the code that we mail to them. Or we mail them the key. So so when a person goes to register an ID hash, maybe we should say this is this creates an association between the Ethereum address that sent it and an identity hash.
Is this contract the contract that will handle all of the memberships, or will there be one contract for each member?
This is the only contract there is.
Okay.
Okay, I mean, it's going to be run by all the members. It's just one contract. And it keeps the mapping of all the Ethereum IDs to all the address hashes. All the identity hashes. All right. So if you want to be a member of RChain, you're going to call, this contract will have an address.
Yeah, I'll go to a web page and I'll enter my address and I'll enter my name and anything else that you decide to.
No, well, that's later on. Okay, right now, you're going to go into your wallet. Okay, and this is a wallet that I have downloaded to my, I downloaded all the pages to my machine. It's a browser-based wallet. I'm not on their website. I'm on my own machine. Just accessing the wallet, HTML file, web files locally. So what I'm going to do is I'm going to go to the contracts tabs, and what is this? I don't want to deploy it. I don't want to deploy a contract. I'm sorry. Go back to settings, and this wants a key store. So I have to unlock my wallet every time I do something, because the only place my private key is kept is on my machine. And it can be encrypted or not. And this address that I just entered the JSON file for was unencrypted, so I didn't have to enter a password. I have another wallet JSON file that's encrypted for an account where I have more money. And it's worth taking the wrong passwords, whatever. Okay, so I'm going to send a transaction. No, I'm going to I'm going to run a contract, but I'm not going to deploy one. Why am I confused? Let me go to my real address. This is the wallet at my Ether. And okay, yeah. So what I have to do here is I add the address of the RChain membership contract here, and I'll see if I look at that contract on the Block Explorer. I'll see it has a. I'll see it has a. So this is a contract for withdrawing the DAO, which I did the other day. I would finally, you have till the 15th, everyone, to withdraw your DAO tokens. So I withdrew that for ETH. Now, in order to run this contract, I look at the contract source tab here, and I see there's a contract ABI, which is the interface to the contract. This tells the contract what variables it needs from me in order to run the function that I want to run. So in order to get a form, in order to be able to fill out the fields that I want, that the contract wants, I have to copy this contract ABI, and then I have to paste it into my wallet. Okay, and I have to take the contract address and put that into the address that I'm sending to. And now I hit the access button. Okay, and then I get to select a function. Trustee, withdraw, main DAO, trustee. I don't know what these other functions do. I did a withdraw. Okay, it's probably the only function I'm allowed to do. So then I said I wanted to redraw, and it asked for me to select a wallet. And then I unlock the wallet, and then I hit write, and it creates a contract. And I get to set the gas limit here. So it generates a transaction, and then this is a signed transaction here. And if I confirm at this point, I'm going to have to pay gas in order to run this contract, so I'm not going to run it.
I got you.
I already withdrew all my DAO tokens. But if I hadn't withdrawn my DAO tokens, I would have hit yes, and I would have gotten a whole bunch of ETH back from the DAO. Okay, so when we run our functions, when we run our functions, we're going to have, for each function we have in the contract, we're going to have
operations that we can,
a thing to do, and it's gonna, I don't know, it's gonna let us fill in the arguments that it needs for the contract according to this interface specification here that's in JSON. So basically, we don't have the user interface written for this to run on our machine. And we don't trust any third party to give us a user interface, so we just call the contract directly pretty much. So this contract, we'll deploy it. It'll have an address. Okay, anybody can send to that address a register ID hash. Okay, it's gonna cost them some ether. So we have to charge, we're gonna charge them membership fee here. The co-op membership fee. Okay?
Got it.
And then we're gonna say that the message sender, the person requesting membership, claims this identity hash. Okay, we're not giving their address over the blockchain. We're not making it public. We're sending a hash instead.
Okay, let me ask you a question about that that hash. Is that hash uniquely identifiable to us?
It's a unique number, yeah. The only thing that can generate that hash is the identity string.
Gotcha.
Okay, if we hash this string, we'll get that hash. So we can prove that the claim of this is true because it has that hash. Well, we could not yet. We can't, but we know that that entry is for this address hashed. Okay, we don't know if they really live at that address or if they're a real person, whatever. But we know that this name, address, date of birth, nationality, whatever we claim, and what specifically we'll put in here is to be determined. Specific factors to be included is to be determined. In identity. In identity. I'm going to say hash, I don't know. To be hashed. Okay, the register. Okay, so we have the so when they register their hash, the hash goes into claimed associated with an Ethereum address who sent the message to the contract. Sent the register ID hash to the contract. Got that? So we're good there, right?
Yeah.
Okay, the set code. Well, I guess what I'm really writing here is the verify code. Huh? Not setting it. And this just sets the address of the sender. And what I want to set the address of the sender to the hash of the address. So I want to set it to the claimed of the message sender. Right?
Right.
Okay, so the validate method why does this set that? I was just modifying this, copying and pasting the same method and then modifying it.
Gotcha.
So this is totally wrong. Okay. Really, anyone can validate the ID hash. We don't really need this. We don't need to throw an exception if the person requesting the validation is not the owner.
Right.
We'll let anybody do that. But then we want to say if the verified by RChain of the who equals the hash I don't know what the best thing to do here, but for now, I'm just going to put in there, if it's not equal to the hash, I'm going to throw. And that way,
You got a typo in that verified by RChain.
I should be typing this into a GUI at this point. I mean, into the into the IDE for Solidity, which would pick up a lot of my errors and pre-fill my fields. But this was just a very raw.
Well, this is just something to talk about for now.
Right. But I would want very soon to do this in the IDE and put it on GitHub.
Exactly.
And I was, I just want to get somebody to look at it and give us some advice before doing that. On the approach, and maybe somebody else would take it on as well. I was hoping to get Jeff Anthony involved. He said he was definitely interested in coaching. And at the same time, in the working session here, we would get familiar with what he does on GitHub. And I don't know what GUI he uses. I sort of wanted to get the whole thing working in Eclipse. Your mileage may vary. Oh, verify identity is equal. Returns bool.
Should be RChain, not arcane.
So this function, what was the purpose of this function? Oh, validate. Oh, validate is what we wanted. Duh. What's the matter with me? The only one who can validate I'm getting confused with what we have here. Okay, we need set code, right? We have the verify identity down here. We have the verify code here. We don't have the set code, right? Okay, and we have an address, and we have a hash. Do we need that? Maybe not. And the only one who can set a code is RChain. So if the owner's not RChain, it throws. But what we need.
That says if owner is not the message sender, it throws.
Yes. Yeah, the owner is RChain.
Oh, okay.
The owner of the contract is RChain.
I got you.
So only they can set the code. And let's say a byte 32 code. I thought I already did this. And then we want to set the Actually, I don't want to use the same variable. I'm going to make that encrypted and make this encrypted. Okay, so that's, I think this makes sense now.
Sort of. But yes, I would like to sit in on the session where Jeff goes over this with us and fixes it.
Right. Well, that's one of the issues is whoever's going to go in here is going to start using all bells and whistles, making it harder to understand.
I see.
I'm just trying to keep it down to basics at this point, but decoding the encrypted here is an issue. Okay, because well, I don't know how to. I mean, I know how. There's lots of ways we can do it. Okay, the code can consist of a large prime and a seed. Right, and we can just calculate, do our own arithmetic to decode it, sort of. And maybe for that matter, maybe I should make it an int 256 for that purpose. But I'm looking for something easy for the person to type. And it can't be too easy, obviously, because then it could be decoded. But why would somebody try to claim somebody else's address? And certainly all their attempts would be shown on the, on the blockchain. I mean, it takes 500 times to validate their address. There's something wrong.
Yeah.
And that's the other thing too. We could make that more expensive. I mean, it's going to cost them some ETH to do the validate. But if it's a $20 fee, we could charge them $10 an ETH to register and $10 to validate. Or something. I mean, that would prevent people from trying to guess it or whatever.
Trying to stuff the ballot box. So this is really just mostly to determine who are members of the co-op, and this will be specifically useful when the co-op starts voting.
Yeah, well, I see. I didn't include, what the structure of a member is here or anything. What fields are associated. I mean, the problem is blockchain is public. All of our information needs to be private. And we can do that with, basically we encrypt things outside of the blockchain. So instead of having like a hash function here, I would have an encrypt function here. And it would be encrypted with an RChain private key, so that only RChain could get it. So there are many approaches to this, but and I don't know. This is a very simple approach. It doesn't really make members of RChain. I mean, this is part of the membership process. It's about verifying an Ethereum address. Okay, I haven't really made provision in this contract for holding other identity factors.
Okay.
Um,
So this is just to get us going.
right.
I thought Greg wanted to have another meeting specifically about membership in the co-op.
Yeah. I think he did.
Oh, he did have another meeting.
I'm sorry?
You say he did have another meeting, or he wanted to?
He wanted to have another meeting. So I guess in the co-op group, I guess we should try to schedule that meeting, and maybe provide a link to our prototype.
Yeah, a link to the prototype and a link to the video, and then announce the fact that we need to schedule the meeting, or we're ready to schedule the meeting now that Greg referred to in the get together.
Right. And we really need to have a mentor or a coach, an Ethereum coach, to help us with this project.
Right.
So I hope Jeff's well. And I'm not sure who else knows Ethereum. But certainly Greg could help. But the last thing we want to do is take Greg's time.
Yes.
The last thing we want to do.
Yes. So maybe we could just schedule the meeting with some of the worker bees, and the worker bees can find some mentors to come in and explain how to do this. And Greg doesn't have to get involved.
Yeah, well, I mean, basically, we've defined a use case here and a certain set of functionality. And what would probably make sense, what might make sense is to generalize this. In other words, Control C. Control F. So I'm going to change this verified by RChain to verified address. And replace all here. Okay, this sort of makes it extensible in that we can We can have other verified things about the person. We can add to extend that that way. And
sort of a primitive identity functionality.
right. You know, we could add we can add another mapping here, which can be the U port address.
What's that?
That's the rich Ethereum address. Rich Ethereum identity. That has all the other functionality we need for identity. That's what we want. Build UPort is made to be flexible, so we can store you know, you can manage all of your persona, all of your pseudonyms under one UPort identity.
Okay.
So we may or may not have a UPort identity associated with the person, which would be the rich identity. It may be sufficient to have a verified address. I don't know.
Put a comment to the right of that. This may not be necessary.
Well, I think it's necessary.
Extended identity if necessary. Right? Yeah.
Or desired.
Or yeah, extended identity for future extensibility or something.
I'll just say optional. Just to show that there's a path to a richer identity. In other words, this
For future needs.
yeah. In other words, if we prove an address, we want to record that in their UPort identity as well as.
Ah.
But we don't want to require, we can't really require a U-port identity. You know, let's bring your own identity. If you want to bring your U-port, bring it. It's
Oh, you bring it, and then this claim gets added to your U-port portfolio.
yeah. So we could have we could have a function here. Um, um, I'll just call it bring U-port for now. Um, and then we can have the U-port address of the message sender equals U-port ID. And we have a to-do. Verify address belongs to U-port ID. And verify address belongs to U-port ID. And for a address in U-port. Okay. I don't know, you know, that's just for future. Whatever. All right, that's simple. Oh. Okay, and then the other thing they may want to add to this is events. Not sure exactly how that plays in, but
What would events do for us?
events would allow us, in essence, to listen for something happening, like somebody registered. I mean, we can always watch the blockchain, but I have to learn how the events work. Also, I mean, I've already forgotten a lot of what I learned about Solidity from lack of use in the last year when I last played with it. But no, that's our assignment. Really, is to study up on Solidity some and get feedback on this and take the next steps, and finish the to-dos that are, except for the future ones. But we want to be able to collect money and register an account on the blockchain. That's what our mission is. And we have to meet KYC, and we have a solution. So, almost a solution. Yeah, we don't want to go too far down the road until ensuring that we're going in a reasonable direction. All right. Anything else today? Before I guess we have been about an hour.
No, this was a good meeting. We just need to work on attendance and people being late.
Yeah. Now, with regard to the factorial implementation.
Oh, yes. Did anyone comment on that?
Nobody commented on it yet, but I guess, I mean, we were wondering, well, where's X here? How is X defined? And, because this is only a prototype of the call. So we're just using any dummy variable name in here. And this continuation of this piece of code here.
So this is actually called a continuation.
Yeah.
Are we still recording?
Yeah, we are.
Okay.
So this is a little piece of code as data, which is, like a lambda expression. Given X, okay, we're going to output K. And n times X. Okay. And we're supplying that for K. And are called the K fact here. So This just says that this procedure takes one argument. And I'm trying to figure where we supply that argument. Okay, if we supply the argument 1, okay, it's going to do it's going to return K1. If we do 2, it's going to do return K1 times the proc of 2. 2 was N. So I guess our question really is, why does this, why does,
Well, what is the definition of proc? I forgot.
Well, we can look at that. It's a procedure. It's a piece of code. It's a lambda expression where if we give this an argument, this process takes one argument, x, and given an x, given the value for x, it produces, in essence, the list k and n times x. And that's, we're definitely missing something here in how this is done. And this is our challenge for someone to complete the loop here. And
what do you mean complete the loop? You mean complete the explanation of the loop?
Yeah. I mean, it's not clear at all here to me.
Well,
X gets the, okay, if we do K fact 2, let's do this. I think maybe we can get this. Do a K fact. Okay.
Was this what Kent was going on to explain yesterday when he went down into the continuation code, and then I interrupted him and said I wanted to go back up and talk about this?
I don't know. We're going to get a K fact. Okay, this is going to give us K fact of n minus 1, which is 1. And then we're going to get a proc of 2 K of K factor 1.
Jim, let me ask you something about Rosette. We need Rosette to be self-documenting some way. How can I figure out what the keyword, we need to be able to find out what the definition of these keywords is, right?
Yeah, that's in it's in the manual.
Well, I know, but a predefined keyword should be associated to a sequence of Rosette base language instructions, right?
So we have X is 2, but so the 2 here became the X here. In other words, that's the argument that's passed. Okay, the one argument that's passed to the function is a 2. So we end up with proc of 2. Becoming K 1 times 2, which gives us the factorial of 2, which is 2. Does that make sense to you?
Yeah, it does.
Okay, the issue was going from, using the arguments here with a,
In a dummy function, right?
well, it's not a dummy function, really. I mean, it's
Well, it does a bunch of stuff, but for us, all we need to know is it tacks it on the end of the carrying out of the function of kfac, right?
so. Let's do one more. And we'll do KFAC of 3 is KFAC of 2
Proc of 3.
of 3.
No, K-fact of 2, proc of 3. You had it right, right?
Of n minus 1, so that's 2. And then we have that the K-fact of 2 which essentially the K-fact of 2
I think I need to go back and look at Kent's video.
okay, so that's what we had for the K-fact of 2. You can just wait. We know that K-fact of 2 results in that. This looks recursive to me. Okay, and then we can but okay, we can execute that. Oh. Okay, so K-fact of 2, I mean, we know is K-fact of 1.
Yeah, K-fact of 2 is just
I don't know. I'm just gonna put in the and I hit a 3. Um, what it should be here is okay. In other words, we have K 1.2, 1 times 2, produced by K factor 2. And so we got K, and so we called it with a 2. In other words, this is evaluated, and we get 2 times 3. All right. We'll see if we can make some more sense out of that. But essentially, I can see how it works, sort of, and I just don't understand exactly what's happening with respect to the processing that takes place. But we can see that that we're going to have how do I have a 1 here? That we're going to do a K factor -1, and then we're going to put in the 3 for the X. And for the N, we're putting in this. Why do I have this K first as the first argument here, and then I have it as the second argument?
Because we only need the K one time.
Well, when I'm making a recursive call here, okay?
But in the definition of the K-fact proc, at the first level, I mean, you look at both variables, but deeper in, you start doing something else with the variables.
Right.
In other words,
we're passing the K first to this procedure.
but we don't want to do the K at every level of the nest. We only want to do the K at the output. It's really a function of only one variable, but we're passing in a string that we want to use at the very end of the operation.
This is K. We're using K here. We're passing K. We're passing this procedure as K.
Oh, of course. That's it. I've got to think about that. I think I need to meditate on that.
Yeah, it's a little bit twisty in the brain. But, you know, so we're passing it a function, a number and a function. And when we, you know, the first thing ultimately we want to print the value.
Right.
So we call it, so we can do print. Okay, now where is the print? The print comes here. Does it?
Yes.
And the print comes here.
So really, what this proc does is it allows you to build on this second argument of k-fact within the recursive calls.
Right. Okay. We're essentially adding to the process that it's going to execute at the end, that it's executing. We're adding on to the process that it's executing. So, you know, print. So the command here, print, doesn't print anything. You know, if you gave that result now, you'd get nothing. But after the first time, it would print 3. It would print 2 times 1. It would print 2 if you gave it a k-fact 2 print. And if you gave it 3, it would print it would print the first argument. No. Yeah. All right, guys. That's enough for today. A lot of long pauses here. It'd be nice to edit them out.
Okay, this is great. I'm making progress. You're making progress. I'm one of not as turtles though. I'm very slow.
Yeah. And, I mean, if people put comments and stuff in the document, and suggested edits or whatever, it could help asynchronously if people can't attend the session. Okay, so
well, that's enough for me today.
yeah. All right. Thank you. And
Thank you, Jim.
we'll see you later. See you.
Bye.